Hello friend, welcome to Dr. Subhash Technical Campus Junagadh. Now today's tutorial topic is PN junction diode. It's simply called semiconductor diode. Now let's take a look. Now PN junction diode is nothing but one P-type semiconductor material and one N-type semiconductor material will attach together and make a one junction. So it is called PN junction diode. Now P-type semiconductor is nothing but it contain majority charge carrier is hole and minority charge carrier is electron. Here N-type semiconductor the majority is electron and minority is hole. This is the symbol of PN junction diode, and inside the PN junction diode in P-type semiconductor this is a acceptor atom, in N-type semiconductor there is a donor atom, means here the majority is electron and here the majority is hole. So this one is about the PN junction formation. Now why the PN junction is nothing but when initially joined electron, means here the majority electron will transfer to the P type material, and here the different hole is available. Whenever electron will fit into the hole, means it electron hole recombination is occurs in this region, there is no any free electron or hole, so it is electrically neutral and electron hole disappear because the ion is completed. So this leave the region in the free charge carrier and depletion layer. So it is called depletion layer region, and there is no charge, so its work as a insulator. So we can say that this region act as a insulator and it not allowed to pass any current. Now barrier potential. According to the width of depletion region, we know that here some depletion region is there. Whenever the electron will move from N type to P type, or hole will move from P type to N type, at that time some potential, the breakover potential is required, and this is nothing but barrier potential. This barrier potential it depend upon the made up of semiconductor diode. Suppose if our diode is made up of silicon, then 0.7 voltage is required. If our diode is from germanium, then 0.3 volt is required. We can say that simply 0.7 minimum 0.7 volt required for silicon diode to turn on, means it allow to pass current from it. So whenever diode is here, we can use diode in two condition. The PN junction is also called as a diode. Now what is diode? The term diode is from Greek roots. D means two and odd means path. Means there is a two path available or two terminal is available, anode and cathode. So it is called diode. It's used in various electronic application. We will use this diode to form transistor and FET, or some diode are also used in the logic circuit. In digital circuit is also used diode. This is the practical symbol of diode. This is the cathode, this is the anode, and this is the symbol of diode. This cathode and this is the anode. Here the white strip indicate the cathode and this is the anode. The two terminal device is diode. Now diode works in two region. The first region is forward bias region and second region is reverse bias region. In forward bias it allowed to pass current from it, and in reverse bias it does not allow to pass. Now what is the condition of forward bias? Whenever anode, this is the anode, this is the cathode. Anode is positive and cathode is negative. When we connect the one battery, this is positive, this is negative, and this condition is known as forward bias condition. And in forward bias condition, this depletion region is very narrower and it allowed to pass current. The direction of current is like this and the flow of electron is in reverse direction. So we can say that this diode is in forward bias. Means you have to remember anode is positive, cathode is negative. So diode is in forward bias. Now in reverse bias the condition is reverse. Here the anode is connected to negative and cathode is connected to positive. So here the width of depletion region is increased and it does not allow to pass any current. So diode is in reverse mode or in open circuit mode. So the resistance of reverse bias is very high compared to the forward bias. So this is the two condition you have to remember. Now, if we draw the VA characteristic, then I versus V or V versus I characteristic, then the two region, forward region and reverse region. In forward region, after 0.7, if our diode is silicon, or germanium 0.3, after 0.7 volt the diode become on, means suddenly increase the current after 0.7 volt. Now in reverse bias there is no any current up to reverse breakdown. Now this is the avalanche breakdown, means whenever we increase the reverse voltage very high, at that time permanently break the junction and it is called reverse breakdown. So this one is about the characteristic of the diode. You have to remember this characteristic. Now this slide you have to remember about the diode. The first you have to remember, diode cannot conduct in reverse bias and diode always conduct in forward bias. For silicon it is 0.7 voltage and germanium it is 0.3 voltage. This is called breakdown voltage, sorry, knee voltage or barrier potential or breakover voltage. The 0.7 for silicon and 0.3 for germanium. If you have any query or any question, then please write to in this email ID chetanb@drsubhastech.edu.in. Okay, this one is about the simply PN junction diode. Now we will meet in next video. Okay, thank you.